Okay, hello and welcome to our finals. It's been a very great year for 3D concrete innovations, and we have worked hard to prepare three best teams to present today the final presentations on technical design competition for how to build a 3D concrete sculpture. In the picture here, you can see the first version, and it's not divided. So today we will see how three teams managed to do the best job of dividing and preparing the sculpture for printing. We will also introduce you to the jury and go quickly over what was the task of the design, what are the evaluation criteria, and of course, prices for participants. So the design task of this competition over these few weeks is to offer the most efficient split and assembly solution for the provided 3D model for concrete printing. So students were allowed to split it, they were allowed to change the geometry and add additional parts. The price pool in total, we have 2,500 euros with partnerships also from companies Printstone and DigiSplit. And the evaluation criteria for jury will be split design, material efficiency, feasibility and stability of the sculpture, and ease of assembly, as well as creative additions. So we will provide you with this again when you score the participants, but definitely take note, especially for the jury members. So if you are watching right now on live stream or later in recording, and you want to learn yourself how to build, divide, and split 3D printed sculptures, we have a YouTube channel where you can follow all the recorded lectures, also from our guest lecturers. And during this competition, we had one lecture. We talked how we designed the first sculpture that is now available in Riga Technical University campus. And then we had two guest lectures from Slava Markin and Roberto Maboni, who are here with us today on exploring the landscape of 3D concrete printing and also how to work with design-driven solutions for low-carbon 3D concrete printing. And of course, there are also older lectures from previous competitions that are available for you, and you can go through and see how to model for 3D concrete printing and also how to split and test the prints. The time frame of the whole competition was approximately 3 months from the start, and now we are in almost the second phase, which will be after competition, where we'll be starting to print test models and also work and see how we can implement it in real life. So probably there will be still some additions and corrections, but we are in a very great place to see the presentations. But before we go to the presentations, we will do a quick round of introductions, and there is no one better to tell about yourself than you. So we will introduce you to the jury members who will be today evaluating. You as both Maris and me are teaching, and then we allow the jury this time to grade you, so it's unbiased. And let's start with Arturs Veiss from ABEK Los in Latvia. A few words about you and what you will be looking for and what's your main experience.
Hi to all. I'm a structural engineering office. Almost last more than 15 years is structural engineering. What I will see and check the most for me is the stability, of course, that it keeps stable all at the end, but also during the erection process, and also ease of assembly. I think one of the most things which is I will take a note. And creativity, hope I will see something valuable also to use in my practical life in future. Thank you.
Yeah, so Artur's role will also be to think which special award is from DigiSplit, as we are partnering there with that company too. So next is Slava Markin, Business Development Manager at Sikkim.
Hello everyone, it's a great pleasure to be part of such event. I hope and wish everyone good luck. To my person, I am business developer for 3D concrete printing here in Germany. Yeah, there is a lot of things going on now and we all tackling the problems. So I'm very curious what was the progress of the students and yeah, good luck guys.
Thank you. It will be needed. And the next is Vance Strautmanis, who definitely is interested how to assemble the sculpture best. And he's from Princeton Innovations.
Yes, hello. It is a pleasure to be here as well. About me, there's nothing to tell about me. I have a passion in 3D concrete printing, and I believe that we will print the first 3D printed concrete village in Latvia soon. So I have experience in building, and good luck to all of you. Thank you.
Okay, and now we go to Nicholas, who is the person who was optimizing code for the last printed sculpture, which will be looking at some ways how it is doable. So a few words about yourself, Nicholas.
Hello, I'm Nicholas. I'm mostly a 3D generalist. I have mostly experience in regular 3D printing, FDM. I wrote my own slicer from scratch, and I'm mostly there to check that the models, the 3D models, are sliceable according to what are the requirements.
Thank you, Nicholas. And rounding off our excellent panel of jury, we have Roberto Naboni, founder and head of SDU Create.
Yeah, hello, my name is Roberto. I am an associate professor at the University of Southern Denmark. I'm an architect by education, and I'm leading a research center, which is SDU Create indeed. We look into computational design and digital fabrication, and 3D printing and 3D concrete printing is one of our main interests. And what I will look into is good and elegant, let's say, geometrical solutions to solve this task. But also I'm interested into evaluating the process that the participants have used and evaluating the workflow for their solution.
Okay, well, now the jury has introduced themselves. It's time for participants to
Maybe
introduce what they have.
Matis,
You want to say a few words?
maybe yes.
Everybody already knows you, but of
Yeah,
course, go for it. Yeah.
Thank you, everyone. Marcinka, Riga Technical University 3D Concrete Printing Lab, one of the initiators of this competition. I just wanted to take this opportunity to say thank you, because afterwards probably we'll congratulate students, and there will be no time for the thank yous, and it will be late. So I want to take this time to say thank you. First of all, thank you to the jury and our lecturers for dedicating their time for this event for the students to raise awareness of 3D concrete printing. Thank you for that. Also for the students for taking this challenge. I think this was a lot harder challenge than on our first 3D concrete competition. Definitely, this was harder one, and we can see it from the number of finalists, definitely. And also thank you to Matis and team and Andra who organized the event. Really nice organization. Thank you. And also, Matis just briefly mentioned, but of course, so our initial prize pool was 2,000 euros without any sponsors. Right now it's 2,500 euros with 2 sponsors. So thank you for that. I think it's also really nice to show this, that some companies are interested in this, that companies are interested in supporting such events. Thus, I think this is also really nice. Yes, I think let's not wait anymore, and let's go to students' work. Thank you.
Thank you, Maris. Very good. Yeah, we usually say thank you at the end, but it's a good point that, that no one is listening anymore. So we should learn from you and rework our schedule. So we will start with presentations, and the first one will be Toms, and after Toms we will have Lennarts, and the closing off we will have a team of Peteris and Ralphs to present the third. So Toms, are you ready? Toms looks ready.
Yes, yes.
So Toms will present 5 minutes, and then we will have time for jury questions.
So my name is Toms Tesh. I study at Riga's Art and Media Technical School. I'm studying their product design, and this is going to be my fairly short split proposal for LabLab V2. So right off the bat, I just want to go over some of the design changes I decided to go with for the actual model. These being replacing a few of the parts on LabLab with 3D printed parts and changing up the shape of the shoulders on LabLab. The reason for the 3D printed parts is mostly to serve as a way to customize LabLab in a way. So maybe for different seasons, these parts could be printed in different colors and then give LabLab like a fresh look in a way. And then quickly already going into the split proposal, I've kind of split this up into 3 parts where these being the legs. I've split up the legs in a way where I try to keep the most amount of straight edges. I try to minimize the like straighten out the base of these parts so they could be printed pretty easily, and all of them can be printed in one piece on the same plate, with a bit of an exception for the very bottom, the very base of LabLab, which if it's going to be printed in a single part, it might come out quite tall, but there could probably be also a way of maybe casting it, since it's going to be mostly just a solid piece, to weight down LabLab, and it's going to serve as a, you know, yeah, it's just going to weight down LabLab and help it with stability. Going into the body, there's a few pictures of how I've split up the body, and you'll probably notice that a lot of the pieces have this kind of a grid system in the middle. The reason for this is mostly because I'm intending the outside to be printed in a single layer. So for stability's sake, for these parts, they will have a grid inside of them, which will also be printed. So it will be one big piece together. And there will be holes later for assembly purposes. For the arms will be just easily printed single parts. They won't have anything in them. They'll just be like the outside part with nothing inside. And then for the head, since the head is, for me, when I was designing the splits or thinking of a way how to split the model, I ended up splitting the head quite like doing a lot of vertical splits, as that kind of allowed me to keep a lot of the body lines of LabLab intact. And I felt like it would allow me to keep a lot of the details and minimize the amount of parts that it would be printed in. But since LabLab set is quite big, it still needs to be split in the middle. So most of the head parts will be printed in 2. And that's it for the splits. And very quickly going over the assembly, this was kind of where I was caught up with for a while. So in the end, I decided not to really overcomplicate it and just go with, I thought, why not really just stack LabLab onto itself? So the holes that you saw previously that were modeled in for the pieces, thick steel rods will be inserted through LabLab to serve as kind of, to keep all the pieces in line and straight, and not let them slide anywhere. And they will be kept into place, like both ends of the rods will be glued into the parts, like here in the base. That's where they start off, and they will be glued in there. They will be glued in there, and then going up to the head, and here in the head part, there will be a bit of a frame made for the head to allow the pieces to be held together. And as for the additional parts that I added that will be 3D printed, I didn't look too far into how they would be attached to LabLab, except for the backpack. For the backpack, it will be printed in 2 parts, so that half of the backpack could be removed and it could be tightened and attached to LabLab via screws. And that is all from my very quick proposal of LabLab V2.
Thank you, Toms. Do we have a question from a jury? Yes, Artur, go for it.
The first question, if you can take back the presentation, you have been split it in several details or the pieces, and then the question, if there is an option that some parts could be merged together. I mean, like, if it's the most optimal count of the parts, and how you evaluate the dividing of the parts, because every part which is divided, you also later on need to connect together, and the connection place is the place which is the one of the weakest parts. So in your own consideration, if there is an option to make something together or merge some parts.
There most definitely are options, most probably in the body section, where some parts could definitely be merged, but I do feel like it needs to be considered, because if we start merging parts, most likely we'll run into the problem of the part getting too tall for the printer to stably print it. So all of these parts are kind of in the optimal range for height-wise for printing, and I feel like some parts could most definitely be merged together.
Then the question is next one. I know that according to safety rules, it's allowable that a man can carry 40 kilograms and a woman can carry 20 kilograms. That's simple. Have you calculated the heaviest part? How much is the weight? Just curious.
Yes, I had a table with all the weights written down, but the heaviest part is about 250 kilograms, and it's at the bottom, very bottom, on the base of LabLab, with another part following around 230 kilograms.
Mm-hmm. Yeah, just about the weight. Maybe it's also a need that to divide just in case to make it smaller, just for easier to carry on. Just a question. And connection between the elements, how you imagine between the elements to connect only with the rod or some else, some other materials?
Mostly no. Well, it's just mostly the rod, but with my original idea of it being, it was meant to be a 30. Okay, yeah, it was meant to be a 30 millimeter rod, but I do really think that there could be like a thicker rod should most likely be used, but this was just what I initially had placed, well thought of.
Okay, thanks. Yeah, that's all.
Thank you. There is Vance. Let's go with Vance's question.
Yes, thank you for your presentation. I would love to tell you, please don't be afraid of weights, because it's concrete and it will be assembled by a crane. It will not be assembled by a manpower. So don't be afraid of weights in this case. About assembling, about the vertical parts, please think about bolts, because if there is only rods or glue in winter, in summer, in winter, in cold, and rain and etc., I am afraid it's not safe to put vertical parts only on rods. Thank you.
Thomas, you are muted, I think. You
Yeah,
need to unmute yourself to answer.
yeah, it's noted. I do feel like there most likely could be ways that we could also kind of take the variable of glue also, or minimize usage of glue so that weather wouldn't really affect it as much. But bolts, I did have some ideas of. It was in my head, kind of thinking how I could use bolts, because those would give a more stable end result. But in the end, I couldn't really think of a way to integrate them optimally, at least.
We have time for one more jury question, if there is one. If not, then we continue with the next team. The
I have
next
a
team will be
question.
Lennart's. Yeah, go for it.
Thank you for presentation. One question is, what is the planet width of the layer? And the next question, how you assure the size of the holes? So how you produce these holes I believe in fresh state, and if they are produced, how you assure the connection between steel bar and the concrete parts?
Yes. As for the layer widths, heights, I was taking into consideration what was given, like those average measurements. So I believe it was 10 millimeter layer height. But I'm not certain immediately on that. As for the holes in the models,
Wait a second. So what the width of the layer? So you on your sketch, you can.
the layer widths. Yes. They are single layers. They're going to be about 40 millimeters, 40 millimeter thick layers, and 10 millimeter high tall layers. If that was the question.
For me, it was also not understandable how you design the code or slice your model. How on the left side the feet of the robot, how you will what will be the movement of the nozzle? So there's cross sections. I don't know. For me it looks like there is not really plan how the printer will operate it.
Yeah, well, that's something that I should have maybe taken a bit of more time, like put more time into, but it was mostly as an idea, just kind of, I knew I wanted kind of cross section, like grids like grids supporting the parts in the middle. So that's how I was kind of modeling it around. But I do understand that it might not be the best when it might not be the best idea when it's actually going to come to printing. So I most likely would have to consult with someone who could help me with that. But previously you asked about the holes and how I would ensure that they would print properly. And the idea would most likely be to use some temporary items that would be of the same diameter, the same shape, that we could insert during the printing process to kind of keep the holes the size and shape that we want, and then afterwards take them out and we would have the holes.
Thank you, Toms. Toms is our youngest participant ever in the 3D concrete competition. So we're very happy, and there's a lot of time to learn, as others are all from university, and Toms is still in high school. But that's really great. We are very happy with the results, and of course, there is some room to grow. Thank you for your presentation and very good answer to the questions from the jury. And now let's continue with Lennart's presentation. Lennart, I hope you can. You will have to unmute yourself to join.
Yeah, can you see?
Yes, affirmative.
Okay, nice. Ah, crap, again. Okay. It's visible all right, yeah?
Of course.
Okay. So this is, I'm Linarts, and this is my proposal of how to split the LabLab statue. So here on the left, you can see basically the main idea. Each part is colored in its own color just to make it easier to see where the splits are. Then in the middle is the textured version, so roughly what it would look like in the actual real materials, and an additional view of how it could look in the night when it would be lighted up by LEDs. So this is exploded view, just to make it clearer which parts are separate. Yeah, basically, as you can see, the whole lab is sliced into flat sections and then stacked together on top of each other, which I thought was simple enough to actually make, and should also not look um, um, out of look unnatural. Like it would fit into the style of a 3D printed concrete. Then there's the parts on the print plate. So here are the short names, the shorthand for the part names, and they are all laid out. So as you can see, they all are hollow, and yeah, later in assembly you will see the attachment. But yeah, so one additional thing I would like to mention is here for the head, you can see it's sloped, and the front visor will attach to that. So just a little detail, just for the slope, when printing these parts, there is going to be a support that is going to be 3D printed, and there will be a little notch to make sure that there's a groove for the visor later on assembly. So yeah, this is the rough idea of how it's going to be assembled. Basically, most connections will be just like in the first LabLab statue. There's going to be rebar placed inside the each part, and then attached together with U-shaped bolts. And yeah, then all the other parts that are going to be on the sides, I'm thinking of just in the process of printing, just putting screws with their um, basically, yeah, putting screws inside the walls of the print, so that the parts on the basically on the sides could be later screwed onto the main body. And yeah, that would be for the backpack, for the boots, for the top helmet, and maybe the connection between helmet and the visor. Also, I did a little bit of calculation, and the center of mass would be, if I remember correctly, roughly 70 centimeters above ground. So that's the marking where it would be. Also, a little note, the plastic parts would also be separate, and yeah, mostly decoration. They wouldn't really bear any loads. So yeah, here's the tables of all the weights and volumes of the main concrete parts. So in total, the printed parts are going to be just a little bit above a ton, and then with the additional casting, it would be roughly 150 kilos additional weight from that. And yeah, the thing is, my approach was that the head of the statue would be most troublesome for stability. So yeah, as you can see, here are basically the parts for the head of the statue, and it's basically the bottom half. So yeah, kind of a trade between weight and then later the cost of the printing the most of the head. And I'm thinking of ASA, which is a filament that is most suited for outside weather. Yeah, it's a bit costly, and so the costs would be a bit below 4,000 euros. So that's roughly my plan.
Yeah, I was thinking, are you continuing or that's all? That's all, yes?
Yeah, that's all from me.
Okay, thank you for your presentation. And now we have an opportunity for the jury to ask a question. Of course, Roberto, yes, you're the first.
Yes, thank you, Linus, for the presentation. I really appreciated your segmentation. I think it's logical. Do what I think also are the limitations of the printing system that you're sticking to. I have a couple of questions. Maybe I missed something, but maybe you have also an occasion to further explain your project. Regarding the first one is regarding the backpack, right? I mean, how do you actually ensure that it is connected to the other parts? I'm not sure you have detailed any connection there.
It's probably not that visible, but yeah, basically the idea is to, whilst printing, just like in the second one, there was rebar placed. Then here, rebar, basically, yeah, while printing, it would be also screws, and the screws would be basically sticking out the side, and then could be used later to attach all the parts on the outside. So that goes for the backpack, the boots, and yeah, the helmet.
Okay, but so the backpack is gonna be 3D concrete printed, I guess. Since you need to have the envelope, like since it's closed, I guess you're printing it basically tilted to the right? So what do you fix these screws to? I mean, isn't it an open geometry there, or is it like casted? I don't get it.
No, I think I didn't make that clear. Probably should have put a list of the 3D like plastic printed parts.
Okay.
Yeah, the backpack is going to be plastic, so
okay. Well, yeah.
Makes it easier.
Yeah, I think it makes it easier because it's definitely more light and it doesn't break easily in tension. But yes, I think you can figure that out. However, I mean, it's something that you need to look at because I mean, I don't know how can you bolt it. Anyways, there is some of the sequence of assembly and bolting and so on that you need to figure out, right? Because it's probably not an accessible part, that one, I would imagine. So this is, I imagine that the gray segments are like bolts, or what are they? Like bolted threads, or are threaded bars, or are rebars? I'm not sure I get that one.
Well, the horizontal would be rebars and the vertical would be so U-shaped bars with the like screws that you could then bolt together with the steel plates to hold the rebar together.
Okay, so there are steel plates in between every segment?
Yeah, kinda.
You have
So
a detail of that because I quite didn't get it, because when I see this, I do not understand what they are attached to. Like it almost looks like a little bit abstract to me.
yeah, I took inspiration from the previous statue, and yeah, probably should have explained the mechanism more. But yeah, it's the bottom rebar is hold place with the U-shaped part of the bar with the part, and then the it's attached to the upper rebar with the steel plate that is held in place with a nut that is screwed on at the bar. Well, yeah, probably should have put a picture with it, but yeah, that's basically how the previous statue was held in place.
Okay, yeah. Thank you for the answers.
Thank you. Do we have another question?
I have a short question. Oh, there is
Okay.
a Vance.
Yeah, let's start with Slava, then Vance,
Yeah.
and then Arturs. So
Yeah,
all of
I
you.
also think we should be careful with the time for everyone, so not with give too much question to a specific team. So please interrupt me if it will be too much questions. So
Yeah, I've tried to keep them short. Yeah, that would be nice.
firstly, thank you for presenting your results. One thing I see here on the design, on the hand, you see the second part, which is light green, and you see that there is an inclination there. I believe this will be is super complicated to print it, so you need to change the height of the layer. I believe with current state of the equipment which you might use, it will be not possible. So I don't know if you consider that or not.
My thinking on that part was that basically the light green and the darker green part, they would be touching with the sides that would be also touching the plate when printed. So that would be smooth, and then yeah, the upper half, the tilted half of the light green part, yeah, there would be problems with the basically, yeah, the angles of the layers. But my intention is to maybe I'm not sure how great it would look in real life, but basically the plastic part might cover up some like weird angles in the part. So might work, might not. I'm not really sure about that.
I believe it will be learning by doing with experience that it will not work. But I understood your idea. I had another question. So these rebars, you want to connect them simple mechanically, bond them together, and there will be no concrete poured inside. Is it correct?
Um, for most parts, yes, but two bottom parts will be filled.
Okay.
Yeah.
Yeah. Yeah. So one short remark, the design in general of this figure is super complicated. This we don't need to forget. So thank you once
That
again.
was kind of the point. Yeah, we really tried to give them something that probably shouldn't be printed in concrete, and then we were very happy with Maris to look and see how they try to find the solutions how to do it. But the next question is, it was Vance, yes, I hope I'm correct, and then Arturs.
Thank you for the presentation. I have a question about the backpack. You thought that the backpack will be plastic printed.
Yes.
About the size, have you found a printer who can print the full-size backpack, because there's limitations in Latvia for big-size plastic printers.
Well, my idea is that basically the outer perimeter of the backpack would be printed in segments, then connected, and then probably the flat side of the backpack could also be printed in little segments and then attached together. So basically, yeah, just a bunch of little parts then added together to make the full backpack.
Okay, and what's the size of the backpack?
I'm not really sure, but I mean, here probably something like 70 centimeters roughly as length.
Mhm.
Depth of the backpack, I'm not sure.
Okay.
Mhm.
Okay, then I can give you a company who can print this in one piece as well. So thank you.
Nice.
Good. So the next question for actors, and then we move to the next team, I suppose. So we can give some time.
From my side this time, not questions, just compliment. I mean, like, very nice that you make in different colors the pieces. We do it also in structural design for beams and slabs, and nice to continue doing that. I was happy for tables, always happy for tables that you have calculated the weights and costs, very nice. And also about the calculation of mass center. Very nice. If you have been thought about that one, I think it will be useful also during the casting time. Thank you.
Thank you, Arthur. Very good, very, very good comments. Yeah, it's always
Thank
nice
you.
to have
Thank you.
just a positive comment from a jury for participants. The next team is Ralph and Lynette. Welcome you to the floor. You have 5 minutes to present, and then jury questions. Oh, the background is great.
Are you able to see the screen?
Mhm.
Okay, great.
Hello, jury, organizers, and participants. I am Pēteris, and together with Ralphs, we will show our solution for this creation of the second version of LabLab. We primarily modified the head and also straightened the body to enhance the appearance when it is printed. So you can see that the arms are straightened out, and the helmet is split into parts that are printed more easily. And so the total height of the LabLab itself has risen from 2.5 meters to 2.7 meters, but otherwise the other dimensions are the same as for the original model. These are the frontal side, top views, and isometric views for easier to understand. And as for the next slide, here you can see that all printed elements are put on the print bed. That is, as our laboratory has 1 meter by 1 meter 70 dimensions, and all elements are designed to be printed with 1K solution, or that is not accelerated concrete, and using a 25 millimeter diameter nozzle with 10 millimeter layer height, but the print lines should be 40 millimeters wide. And for the where needed, for some parts, concentric infill is used. And for some of the biggest elements, the height, for example, for E14 element, that is the biggest element we have, is 38 layers, so 38 centimeters high. And E15 is 33 layers, and the rest are smaller. And as for utilization of the print bed, element E17 is using almost all of the print bed, so it is 1 meter wide. And additional elements, we thought of plexiglass visor that would be manufactured at RTU in collaboration with other laboratories. And the main thing on how to produce it, it would be male to female mold and heating up the plexiglass so that when the molds collide, it will create the shape, desired shape. Also for the feet or the soles, we thought about using recycled tires from tractors or other big machinery. And for the backpack, to close it off, we thought of a wooden door. And also behind the plexiglass visor would be 2 LED panels that would shine through the one-way mirror film of the plexiglass and create sort of eyes for LabLab. And the controller to access these panels would be stored in the backpack.
Yes, then moving on to the assembly of the sculpture, we decided to use the combination of reinforcement bars, bolt plates, threaded U-bolts, and a steel frame. During the printing process, rebars will be embedded into the printed elements and then later linked together using the U-shaped steel rods, as it is shown in the upper right corner. And then a steel plate with nuts, yeah, and it is used for strong horizontal connection. For a vertical connection, we plan to use a welded steel frame made from L profiles. That's in dark green color, ensuring the stability and head support. The vertical profiles will be cast into the bottom section, while the horizontal profile will be welded after assembling up to the shoulder part. And to further reinforce the structure, head parts will be glued together using with the epoxy paste adhesive intended for cold weather. That's in this right hatch. And yeah, that's about the assembly. Additionally, we intended to use the spider crane for lifting the parts. And yeah, the lifting capacity of the crane is sufficient for this purpose, according to the load chart. And yes, we also intend to use this Hilti mortar and then Sika adhesive. Then about the specification of this sculpture, there are a total of 21 separately printed parts. The total weight of this object is 2.6 tons, and the printed weight is 2,480 kilograms, and the cast weight is 160 kilograms. And the heaviest part will be this E4, the bottom part, which will weigh 270 kilograms, which is printed, and then additionally 106 kilograms cast concrete. And the volume of the sculpture is 1.2 cubic meters, and of that, the printed volume is 1.1 cubic meter, which is roughly 50% of the relative amount of fill from the total volume. And then the cast volume is 0.07 cubic meters. And for additional elements, yeah, for assembly, there will be used reinforcement bars in 3 different diameters, 2-component epoxy paste adhesive, injection mortar, and welded steel frame. And then for creative part, rubber outsoles, wooden doors, polycarbonate visor, and LED panels. And the total cost of these additional elements is roughly 1,100 to 1,350 euros.
Yes, and for the structural load evaluation, the vertically stacked parts that exclude the feet of the lab weigh approximately 24 kilonewtons. And when calculating it to the design load, we get 33 kilonewtons. The snow and wind loads are not calculated here, but they seem insignificant for this small structure. And so the bottom area of the printed element, you can see here, the colored in red, is 0.2 square meters. So by calculation, we get that the resulting pressure on the bottom part is 0.16 megapascals, which for normal concrete that has 20 megapascals is utilizing only for 0.8%. And that's it.
We're open to your questions. Thank you.
Yeah, so the jury, now it's your time for questions.
Yes, thank you for your presentation. I really love the eyes. Actually, a few weeks ago, I saw a heavy vehicle, a truck with LED lights in the front window, and these eyes were even blinking. It was really nice, childish, but nice. I love it. About the feet, about the soles. Please check the dimensions of the boots. Maybe a heavy vehicle or tractor tire will be too heavy. Maybe there is on this area will be enough with a SUV tire or something. Maybe I can donate one of them if you need as well. About the construction, about the building, actually everything looked good. You really did your homework, and there's nothing I can add actually. Thank you.
Good. That's a nice thing to hear. So the next one is Roberto. Yeah, I think you raised the hand, and then we follow with the next jury members.
No, I think it's very good work. I really love the level of detail. So then you're not really wondering because you explicitly describe every single decision. I'm happy that you're also showing the filament, because I think a big part of the quality of such an object is how you discretize it, not only into parts, but into actually tool path. And I think we mentioned this in the previous meeting we had. So it's really, really good. I was actually having I look a lot of this detail of how you are gonna put it together and reinforce it. And I was curious about the top part, so where there is the helmet. I mean, is it going to be easily accessible where you start having this inclination and you have to actually bolt those parts together? I mean, do you have enough space? You need to put your hands in to connect those parts. I'm looking especially, well, from the moments where you have those inclined parts on the helmet.
Yes, people will be lifted with the crane also, and the vertical reinforcement bars that you can, or the sloped ones that are glued into the bottom parts, they would already be glued before the let's say installation of the sloped concrete segments. So the only thing left at the installation part would be tying them with the wire reinforcement ties, and otherwise I don't think that it would be a problem.
Yeah, and also this opening will be about 50 centimeters wide, so I think there will be enough space for hands to tighten the rods.
Yeah, very good. I have just another small question about always these things. The rest is really good and complete. I'm just wondering, so this is like 14 millimeters, these horizontal rebars. You're gonna really bolt them together, and they will work. They will deflect a little bit if they are too long. I mean, have you checked if any of these is probably too long, and you know it will deflect a little bit too much? How, I don't know if it's gonna be a problem there or.
Well, in our opinion, the diameter of 14 is large enough. So the longest span of the reinforcement would be a meter. Yes, they could bend, but that is kind of you use if it bends, it is like a spring for a little bit. So in case if there is summer or winter heat, it needs to bend a little bit in order to compensate for that, I think.
Okay, it's good that you thought about it, but congratulations. I really like your design.
Thank you, Roberto. And did we have another question? Arturs. And then Slava, yeah.
Yeah, and for me, yeah, of course, nice detailed design. Just a suggestion that try to not fully, when you will start to make it, I think that there will be needed some adjustments from the practical parts. So don't be like also focused only structural design, what you have done on paper. I think that you just write notes, take examples from other projects, and update and keep on working these projects from the practical side also. Thank you.
And now a comment from Slava Markin.
Yeah. So compliment from my side, well done. Of course, as mentioned by colleagues, there is some things which should be improved, but still, I also see that you have done a lot of thoughts and there is some good decision. Well, if I see that you use the bonding agent Cicadur 31, basically you can even use the bonding agent without any rebars. But to be sure, it's a good idea to use the rebars. But in general, you can actually place it between the all parts to be sure that even if there is some issue with deflection of the rebars or whatever, you have all parts glued together. Yeah. So thank you.
Thank you. That was a very good comment. I also see that it's great that they use the product from the company. So thank you all for the presentations. I think we can stop the screen share. And now we will do the most important part, which is basically we will start the break. So Andra will pause the live stream in a few minutes, and then we will have a 20-minute jury break. After which we will continue with awarding the teams. I would only say that already you all here are some kind of winners as you all get to the finals. In the beginning, we had a lot more applications, and through the workshops, you are the most enduring and most strong teams. So that's already a great result. But now we will see who wins and who gets the additional awards. So basically, you will be put in a wait room, and after 20 minutes, the jury will come back. And for the jury, we will put you in the jury room where you can talk among yourselves and assign the prizes. Can you hear me? Welcome back. The jury had some time to evaluate. I see that hopefully all participants are here. Yes, we have Linards, we have Tuoms, and we have Ralphs. And Petris is also here present. That's very important. So I think one important point is, as I already mentioned, that all of you are winners, but we have 2 sponsor awards and 1 main award. And we will start first with a short comment from Arturs. He will be giving you the design award. So Arturs, maybe give a few comments on the teams and why this one won the design award, and then I will show the slide.
First of all, it was really interesting for me to see all the presentations, and I think it's a good study for theoretical side and from practical side, how do it not only to create, but also think how it goes in one element at the end. And so seeing all these presentations together, we have been decided that the design award goes to Tuoms. Really nice that you did this great work, and I hope that you will continue on the improvements and working on this project.
Okay, big applause to Toms. So a design award in collaboration with DigiSplit goes to Toms. Welcome. So Toms says thank you to everyone who supported him on this long way. Yeah.
Thank you. Thank you.
So the next award will be announced by Events. So Events award will be Best Split Award. So here you go. The floor is yours, Vent.
Yes, thank you one more time all for your presentations. Everyone did a great job. Someone was better in some special small parts, but everyone is a winner. And I hope to meet you again, all of you, maybe in one team all together someday in a first Baltic 3D concrete printing farm. Who knows? But now, best splitting technology award goes to Leonard Edgar Squinch. Congratulations.
Yeah, so a large round of applause to Leonard, and this award goes to you in collaboration with Princeton Innovations.
Thank you. Thank you.
And now, interesting, who has won the Grand Prix? That's still unannounced, but we will give a floor to Roberto and Slava, who were with us during the mentorship and hopefully also helped the team to get there. And maybe a few words from your side.
Yes, absolutely. First of all, it was really nice to take part into this jury and see this trajectory. So yes, the Grand Prix prize from my side goes into the solution and the project that was the most complete and has a lot of details in there and a lot of thoughts and very good explanation. So maybe Slava wants to add on that.
Yeah, congratulations, guys. Congratulations to everyone, but also the team who done a very good job, which was distinguished. The job was distinguishable from others, and that's why the team of Peteris and Rives receive the major prize for €1,500. Congratulations,
yeah, so the Grand
guys.
Prix is yours. Congratulations.
Yeah.
Do you want to say a prize acceptance speech? Then the floor is yours. Yes.
Thank you, jury. Thank you, organizers. Thank you, Ralphs. Thank the other participants. We really liked this competition. Ralphs, what you have to say?
Yes, I think it was a very good exercise to do this kind of task, and it's something very different from the common tasks in the university. So yeah, I think it was a nice experience and a very valuable one. And yeah, thank you you all.
Well, thanks to all the participants, to the jury, and also everyone else. It's very nice that Maris already said the thank you in the beginning. So now we can wish you all a great evening. And then let's see you when we open when we start printing. We will be very happy to have you as guests, and of course celebrate the opening of the sculpture when it's built. Yeah. Mari, do you want to say some more closing words, or this is this is enough for now?
Okay, we have. I also want to congratulate all the winners and the winning team. Thank you for the effort that you put in. Because one of the aims for us when we started this, we wanted to actually understand how we will build this thing. Because we had, let's say, agreed that the design will be more or less like this. But it was quite challenging to figure out actually how it will be built. even with our knowledge from the first sculpture. Thus, we wanted to brainstorm. The task here was actually it's a brainstorm. We give some feedback on the brainstorm, and then students come back with some ideas. So I think we have achieved what we wanted out of this competition for us, and also we wanted to give some new knowledge to the students, so the community grows. Because as Vance told, we need people who are interested in this, who wants to print, and I think everybody is a winner. So yes, we will try to print it, and we will keep you updated on the process as well. So thank you to all.
Thank you, Maris. Very good closing. So last but not least, remember, if you're interested in 3D concrete printing, you can join our Facebook group where we share all the news articles. Basically, Maris sends them to me to LinkedIn, and I repost them there. And otherwise, if you followed all this series of 4 lectures and you want to try yourself at some point later to split the lab and see if you can do it better, so the file is still available there, and you can always try to do it yourself and see what you come up with. Who knows? Thank you all, and then see you all in the next events. Goodbye.
Thank you. Bye.
Bye. Thank you.
Ciao, ciao.